So this is going to be a little two-part talk. I'm going to talk a bit about Oracle Cloud Infrastructure, which is Oracle's new cloud. And then after that, my colleague Paul is going to talk a bit about OKE, Oracle Kubernetes Engine, which is our managed Kubernetes service. We joined the CNCF as a platinum member, and he can give you more detail on that. One other thing I'll talk about in addition to the cloud itself is our partnerships. So my role is a very un-Oracle sort of role. It's focused on working with ISV partners, independent software vendors, and getting their workloads running on our cloud. And these are companies you might be surprised to see us working with. NoSQL vendors like MongoDB, DataStax, the company behind Cassandra, and so on. Cool. So this slide's kind of fun. This came up over the last week. We've kind of been talking a bit about tech debt. And the London Underground's a great example. I lived in London for a few years, and it's kind of miserable. It only has local lines, it doesn't have express lines, there's no air conditioning, so you're constantly sweating through whatever clothing you're wearing because you're crammed in with 1 million people. That said, it was an engineering wonder when it was built in the 1860s. Contrast with a brand new subway I got to ride recently in Chengdu in China. Spacious, wide open spaces, perfect air conditioning, plenty of lines, very well designed, learning from everything that's happened over the last 150 years. And you see this sort of phenomenon again and again with very infrastructure-heavy systems that require large capital investments. The charge systems are another great example. So the US had the first credit card system in the world. It's probably the worst. Depending on how old you are, you may or may not recognize the little slidey thing with the carbon paper. We still use those if the power goes out. Whereas Europe's on chip and pin, and then Asia's doing crazy mobile payment stuff that's even further out there. Similarly, telephone networks. You can argue.
Could you speak louder?
Oh, okay. Yeah, I'll try to speak louder. Sorry about that. Yeah, similarly, telephone networks. Arguably, the US had the very first one. You can debate it, but I think we can all agree that that wired analog network is not nearly as good as what we have today, though the countries who are now building the best cell phone networks are countries that even a few decades ago had no telephone network whatsoever. So Qatar is actually one of the first places in the world to be deploying 5G, something we don't even really have yet. So you'll be unsurprised to hear, I think this figures into the cloud. So in past roles, I've worked a lot with various other clouds, and our main competitor, Amazon, kind of got there first, and they've built this enormous market share, a very good product, but because they were the first, they were forced into certain design decisions. Other things where they didn't maybe understand the full implications because nobody had built a cloud before. One of my favorite examples of this is infrastructure as code. So I spend a lot of my life writing infrastructure as code templates to deploy things on the cloud. Amazon's solution there is called CloudFormation. Azure has one called Azure Resource Manager. It's both JSON-based sort of markup-y things. Google came a little later, and I like theirs better than both those. It's called Deployment Manager. And it's kind of cool because you can express deployments as JSON or YAML or Python that renders down to JSON. And that allows you to be a lot more flexible. However, what all three of those examples have in common is they're tied to a particular cloud provider. By being so late to the party here, Oracle's been able to take advantage of a cross-cloud innovation, a new technology called Terraform. So we, once again, in a very un-Oracle way, don't actually have a proprietary infrastructure as code product. Instead, we just use Terraform to deploy on our cloud. Plenty of other examples of this, but I think that's an interesting one. And that figures into one of these differentiators I have up here. We're trying very hard to build an open cloud. And if there is an open source project, we try to take a dependency on that. And we're also contributing things back to the community. So while some of our competitors have function frameworks, for instance, that are closed and tied to their particular cloud, we've contributed a CNCF project called the FN project, which is a serverless function thing it's really neat. It's portable, it supports any programming language, it's fully open source, and then we're offering it as a service. So that's one piece. Beyond that, once again, a little late to the party, so we're trying to buy market share. As a result, we're underpricing the competition dramatically. One example would be we recently spec'd out a system to run a NoSQL database called Couchbase. Worked out to about $1 million over 3 years on AWS. Contrast, it was about $400K on Oracle Cloud. The last one here, which probably won't surprise you, is we're building a cloud that's very good at running Oracle workloads. So we have a managed version of Oracle Database, and then all those Oracle apps you may have bumped into at various times in your career. Think things like Siebel, EBS, JD Edwards, all the Oracle SaaS stuff. We're a very good place to run that. Cool. So as far as the actual infrastructure of the cloud, it looks much like any other cloud you've probably encountered. Made up of regions scattered all over the world. We're madly building those out and investing in new regions constantly. I'll show you a map in a second. Within those regions, they're made up of one or more, we call them availability domains. Same thing as an availability zone you may have seen elsewhere. That provides HA and FT, while the regions provide geographical resilience. Physical network made up of virtual nets, made up of subnets with security groups on top if you want to lock ports and all that kind of stuff. Then we get to the neat part. So you see that bare metal thing there. Oracle Cloud was originally launched in 2016 as Bare Metal Cloud, and some of my colleagues should have some great stickers that show a bear playing a metal guitar, hanging out on a cloud. It's an awesome pun. Maybe it doesn't work in Polish. But that bare metal cloud is a great differentiator, and it's just one example of how we're trying to get really close to the hardware to get very high performance. And that's allowed us to win a bunch of workloads in the high performance computing space, doing things like wind tunnel modeling for car manufacturers. Similarly, in the storage area, very high performance NVMe storage on those bare metal machines, block storage using SSDs. That block storage actually outperforms AWS IO1, but costs less than GP2, their cheap offering. So kind of best of both worlds there. Right, so region build out. 2 regions in the US right now, one in Canada and London and Frankfurt. These are the regions coming this year. There are, of course, plans for more in the coming years. We're really excited about the Japan regions as an example. So lots of things coming. How am I doing? Okay, so I should get to demo stuff soon. I already talked a bit about Terraform. It's a really neat technology. So infrastructure as code, one framework can hit any cloud. We've taken a hard dependency on that, and we've also open sourced the provider we wrote, and that's hosted up on HashiCorp's GitHub org, where you can see issues, make your own pull requests, do all those normal open sourcey things you'd expect. Right, so let's take a look at this thing. So I am going to open up a window to the Cloud Console. And, oh, actually, let me show you something first. So So if you would like, we have, there it is, $300 free trial. So everything I'm going to show you, you just go here, you sign up, you get $300 of credit to use the cloud and fiddle around. So this is the console. Once again, kind of what you'd expect. All sorts of different services available, and we're constantly adding new ones. So like compute, I can go view the instances I have. And I know this region doesn't have a lot of stuff spun up at the moment, but I believe over in Phoenix I should have a bunch of things. Okay, so you can see a whole bunch of things. So like this Sparkline thing, I guess one of my peers must be doing some work with it. Sparkline's actually really interesting. It's Apache Spark Accelerator that Oracle bought a little while ago. Makes Spark queries run really fast. And you can see all sorts of other machines running. Here's one that I guess is doing something with Tableau, one of our BI partners. Looking back at the console, there are two other things I want to show you. So one is this resource manager thing. And this is about to GA. So I mentioned right now we have Terraform as the provisioning layer. So we got this resource manager thing. We're already using Terraform, but this is Terraform as a first-class managed service running up in the cloud. So like I can click here and I can see a few stacks. This one looks like something's wrong with it, and Colin's actually one of the guys on my team. Let's see what he's been up to. So it looks like he tried a bunch of things, they didn't work, and then something did work. And you can see the actual log. If you've used Terraform before, this is just the normal Terraform output. We just this last week at Oracle Open World Dubai launched our new marketplace. And this is part of our open strategy to really embrace partners and run any workload, not just Oracle workloads on our cloud. So you can see a few things up here. They're not a lot, they're like 20 listings so far, but I'll show you in a moment kind of what we're planning to put up there. So that's a quick what we're looking to build console with my team in particular. So my team focuses on big data stuff. And one thing you should notice from this is a lot of this, it's not Oracle stuff, and it competes with traditional Oracle stuff. So once again, open cloud, trying to bring any workload here because it's a really inexpensive, performant place to run all of these. The NoSQL vendors, a lot of that's already been built out. Terraform that will deploy arbitrarily sized clusters. And then a space I get really excited about are the AI and ML things. So last year we bought a company called datascience.com. The name's kind of a giveaway as to what they do. So that we're relaunching as a first-class service on Oracle Cloud. In addition, we're partnering with a bunch of companies to build out integrations for their products. A week or two ago, I got to go to H2O World. H2O is one of my favorite partners in this space. They have an open source framework for machine learning that's pretty widely used and embedded in all sorts of things. For instance, datascience.com uses it. And more recently, on top of that open source framework, H2O3, they've built something they call driverless AI. And it's not related to self-driving cars, it's more related to how can I make machine learning really, really accessible for people who don't have a doctorate in statistical learning theory. Provides a great UI interface. You just import some data, it does a bunch of automated feature engineering and tries to build models. Really cool product. And it runs on OCI on our GPUs, really, really fast. So two examples of ISVs, brief demo, and then I'll hand over to Paul. So first example, Cloudera. Cloudera has been an Oracle partner since, 2011. In 2011, we launched what's called an engineered system. So this was basically the old Sun hardware, like really fast performance stuff running pre-installed Cloudera. Of course, the world's moved on a bit from appliances and so forth. So now a lot of our focus is how can we run Cloudera really, really well on OCI via this Terraform. To build that out, we actually hired a guy who used to manage Cloudera clusters at Wells Fargo and American Express, and he's been building out that Terraform and helping our customers deploy it, deploying clusters in the hundreds of nodes. It's really cool stuff. I'll draw your attention to that little graph at the bottom. Those are some benchmarks he did, showing running a TerraSort on different machine types, normalized for number of cores for the entire cluster. The 4 you see on the left there are different OCI types with the price to run that TerraSort. So however long it took, it cost, $20, $30 to run it. At the same time, those 2 bars on the right are running that same workload on Amazon. So this is some pretty hard data showing we are pricing this cloud very, very inexpensively. Okay, and then this is what I'm going to demo to you guys real quick. DataStax, actually a company I used to work at, so I have a particular warm spot for them. But they're the company behind Apache Cassandra, which is a wide column NoSQL distributed database. The most famous customer is probably Netflix. If you've ever used Netflix and say paused a video you were watching and came back to it later, the point in time you paused, that was written to a Cassandra database, along with many, many other things. At a trade show a while ago, they mentioned they were running about 9,000 nodes of that. So very scalable product. The DataStax version embeds some additional stuff. So it adds Spark, it adds Solar, and it adds a really neat graph database written by the same guys who wrote an open source graph database called TitanDB before DataStax bought their company. So, quick demo, and yeah, I have a few minutes to do this, and then Paul can talk to you. So, think about what I'm doing. This is a GitHub org that is currently private, but we are planning on publishing publicly soon. And it has a bunch of these integrations to various things. But the one I wanted to show you guys is DataStax. So here's the repo, just to show how we're working with partners a bit. Got a couple people contributing to it. So me, this is a guy on my team, and this is a guy at DataStax, all working together to build these out. And this is really part of our focus. How can we partner with people? How can we build an open cloud? How can we all work together? In the repo, there are a few different things. There's some Terraform files, things like the variables file. You can sort of describe your cluster. How many nodes do you want? What version do you want? All that kind of thing. So if I actually want to run this, I go back to the console, and I've already cloned a copy of this locally. You can see I have a copy of a bunch of stuff. So here's my local copy of that. If I go into simple, here are the actual Terraform files. And to deploy this, I just run the same normal Terraform commands you'd run anywhere because, hey, it's Terraform. So Terraform init pulls down that provider. You can see current version, I guess, is 3.11. We're really excited about Terraform 0.12 coming out because that's going to have a bunch of features like for each loop and stuff that are going to make this a lot more powerful. If I want to see what this is going to do, I can run a command Terraform plan. And now that goes through and it describes all the things it said it would do. So it figures out what's already out there and it sees some changes to rules and so forth. So this takes about 5 or 10 minutes to run in sort of cooking show fashion. I already ran one of these before, so we don't have to wait for it. So this is the output. When it's all done, it spits out 2 URLs. One's to DataStax Lifecycle Manager, which is their tool for upgrading and adminning clusters, and another is to DataStax Ops Center, which is their sort of operational runtime administration tool. So if I want to take a look at the cluster, I can copy that URL, and go back to my web browser over here. And of course it can't be reached. Well, that's wonderful. That is very strange.
Are you actually on the local Wi-Fi?
I thought so.
Because the local Wi-Fi has a...
Oh, is it blocking the port? Oh no, I tried SSHing, but I didn't try the port.
Yeah, because during the workshops we opened 22, but... Set up,
I just paired it with my phone. Look at that. Real-time fixes. Of course, my phone is 30 feet away in my bag, so this is maybe not the fastest thing in the world. Okay, so that's Op Center. The username and login were specified in the in the variables.tf file. So if I don't really need to remember that. If I click there, it logs in, and yeah, this is excruciating because the phone's a little far away. So this is DataStax Op Center showing a cluster. So we can see 3 different nodes up and running in OCI, and I can sort of mouse over and see what anyone's doing. So like this one has 48 gigs of storage free, only using 4 gig. Thank you so much. And another thing we see here is its IP address. So I'm going to grab the IP address of that node real quick. Looks like I'm a minute over, so I'm going to go really fast. And I'll try to begin that a bit. So if I go SSH to, these are running Ubuntu. Note we're running Ubuntu, not Oracle Linux. Once again, open cloud. In this case, DataStax supports more modern versions of Ubuntu than it does OEL, so prefer that. SSH to Ubuntu at, and well, okay, good. And I can see, it's just a normal Linux box. It has stuff. If I want to connect up to the cluster, I can run the standard Cassandra command CQL shell, Cassandra Query Language Shell, and specify the standard username. It's Cassandra admin, and there you go. You see a Cassandra cluster. Do things like describe key spaces and see the default key spaces. If I want to use the Op Center key space, always has good stuff in it because it has monitoring detail even if we haven't been actually using it. I can run describe key space, and this gives me the definition of that whole key space. Somewhere up here there'll be a little interesting bit. You can see this is running using a network topology strategy in one rack with 3 nodes. I can also do simple queries, so I can do like a select star from this table name in here. Oh yeah, need a colon, don't I? And I can see some data. So that's kind of what I had. Basic takeaway is very neat new IaaS. We think it's ahead of where the other guys are because we don't have that tech debt, and it's super open. You can run things like Cassandra up here, or really anything else you want. So with that, I'm going to kick it over to Paul, and he can tell you about Kubernetes and stuff.